We move through the world with a quiet confidence that certain things simply cannot happen. Objects fall downward, causes come before effects. What exists must obey rules, and those rules feel so stable that we rarely notice them at all. This sense of certainty is not learned in classrooms. It is absorbed slowly, through repetition, through a universe that behaves itself just enough to feel trustworthy. Science is built on that same feeling. Long before equations or experiments, there is an assumption that reality is consistent, that the universe does not change its mind halfway through a calculation, that if something is impossible today, it will remain impossible tomorrow. Without this assumption, prediction would collapse, measurement would lose meaning, and explanation would have nothing to stand on. Most of the time, this works perfectly. Bridges hold, clocks tick. Light behaves the way light behaved yesterday. The success of science reinforces the belief that the boundaries of the possible are well mapped, even if not fully understood. We trust that what cannot happen is safely locked away beyond those boundaries. But hidden inside that trust is something fragile. The rules feel permanent only because they have not yet failed us. They feel absolute only because we have never seen them bend. Science depends on these unspoken agreements with reality, agreements so fundamental that they are rarely written down, and occasionally, without warning, reality stops honoring one of them. That is when certainty quietly fractures, without noise, alarms, or explanation. There is a rule so basic that it rarely earns a name in everyday conversation. It sits beneath formulas, beneath instruments, beneath every successful experiment ever performed. It is the reason engineers can design machines before building them, and the reason predictions made on paper survive contact with the real world. Without it, knowledge would reset every moment. Every piece of modern technology leans on this rule quietly. Satellites stay in orbit because the rule remains true at thousands of kilometers above Earth. Computers function because electrons behave tomorrow the way they behaved a moment ago. Medical scanners, power grids, navigation systems, and communication networks all assume that nature does not improvise. They assume consistency, repeatability, and obedience. The rule feels inevitable because it has never given us a reason to doubt it. A circuit does not suddenly decide to reverse its logic. Gravity does not weaken out of curiosity. Chemical reactions do not pause to reconsider their outcomes. The universe appears to follow its own habits with unwavering discipline, and we have built our civilization on that discipline. This is why the rule is rarely discussed. It feels less like an idea and more like a condition of existence. To question it sounds almost nonsensical, like asking whether reality plans to keep existing tomorrow. Science progresses by exploring unknowns. But this rule is treated as untouchable, the background condition that allows exploration to happen at all. That quiet dependence is invisible precisely because it has always worked, hiding its importance behind success, so complete that failure feels unreachable, even in principle, to those who rely on it. If this rule were to fail, nothing dramatic would announce it. No explosion, no warning. Reality would still look normal, while slowly becoming impossible to predict. The experiment began the way most experiments do, quietly. No press releases, no anticipation, no sense that anything important was at stake. A group of researchers set out to measure a familiar effect under controlled conditions, repeating a procedure that had been performed countless times before. The goal was not discovery, but confirmation. Check the numbers, verify the calibration, add another data point to an already settled picture. The equipment was standard for the field. The setup followed published protocols. The environment was stabilized, shielded, and monitored. Nothing about the work suggested risk or novelty. In fact, the experiment was considered so routine that its outcome was treated as a formality. The prediction was known in advance, written down before the first measurement was taken. At first, the data looked ordinary, within expected ranges, within acceptable error. Then a subtle discrepancy appeared, small enough to ignore, easy to blame on noise. The team recalibrated the instruments and ran the sequence again. The discrepancy remained. They checked the timing, they checked the temperature, they replaced components that might drift or degrade, they rewrote parts of the analysis code, then rewrote it again. Each correction narrowed the uncertainty, and with each improvement, the mismatch became clearer rather than smaller. This was the point where most anomalies disappear. Measurement errors usually confess under pressure. Statistical flukes dissolve with repetition. Everyone involved expected the same ending here. Instead, repetition sharpened the problem. The result stayed just far enough outside prediction to be uncomfortable, but not dramatic enough to dismiss everything else. It was not a breakthrough. It was an irritation. It carried no obvious explanation and no clear path forward. The numbers were consistent with themselves, stubbornly stable across runs and days. Nothing about the setup violated known limits, yet nothing about the outcome fit comfortably either. The anomaly lived in a narrow space where it could neither be celebrated nor ignored, demanding attention without offering insight, while remaining quietly resistant to interpretation by the existing theoretical framework. So they treated it like one. They fixed everything they could fix. The result didn't change. When experiments create confusion, scientists usually retreat to mathematics. Equations are supposed to clarify what instruments cannot. They strip away noise, isolate variables, and expose mistakes with an almost ruthless efficiency. If an observation feels strange, the math is expected to either explain it or quietly reveal where the error lives. This has worked for centuries, and it has earned mathematics a kind of quiet authority. In this case, the expectation was simple. When the data were translated into equations, the discrepancy should disappear. A misapplied assumption, an overlooked approximation, a boundary condition handled too casually, something would surface. Instead, the calculations made the problem sharper. Each step followed established rules, and each result flowed cleanly from the last. The equations did not explode into contradictions. They did not signal impossibility. They calmly described a situation that should not exist. According to the formal structure of the theory, the outcome fit perfectly, as long as one accepted that a forbidden behavior was being represented without resistance. This was deeply unsettling. Mathematics is not supposed to permit what the theory forbids. It is meant to enforce the boundaries of possibility, not quietly redraw them. Yet here it was, doing exactly that, offering a consistent description of something the physical interpretation refused to accept. Attempts to modify the framework only deepened the issue. Adding corrective terms removed the anomaly mathematically, but introduced new contradictions elsewhere. Simplifying the model restored elegance at the cost of accuracy. No version of the math produced both comfort and correctness at the same time. At some point, the role of mathematics shifted. It stopped acting like a filter and started acting like a mirror, reflecting an uncomfortable possibility rather than shielding anyone from it. The equations were not misbehaving. They were doing exactly what they were designed to do, following logic wherever it led, even if that destination felt unacceptable. The numbers were not wrong. That was the problem. Eventually, the finding could no longer be described as an anomaly. It had shape, boundaries, and repeatability. What the researchers were seeing was not a fluctuation or a rare event, but a stable feature emerging from the data itself. Something was present where, according to the underlying framework, nothing should have been allowed to persist. In simple terms, the system appeared to produce an outcome without the usual prerequisites. The sequence that normally guarantees order was bypassed. An effect appeared without a corresponding cause that could be located in time, space, or interaction. Not dramatically, not explosively, but quietly and consistently, as if reality had skipped a step and continued on anyway. This directly violated the rule that had always held everything together. The rule assumed continuity, predictability, and a strict accounting of how states transform into one another. It required that every result be traceable, that nothing emerge without paying a cost somewhere else. The discovery respected the mathematics but ignored the intuition behind it. What made this worse was its restraint. The finding did not grow, spread, or destabilize the system. It simply existed, embedded within otherwise normal behavior. Remove it, and the model failed. Leave it in, and the interpretation became uncomfortable. The universe appeared to be following its rules while simultaneously undermining their meaning. It forced an uncomfortable reinterpretation of what the rule actually guaranteed. Perhaps it never promised impossibility, only improbability. Perhaps it described averages, not absolutes, habits rather than laws. In that framing, the discovery was not a rebellion against nature, but a reminder that consistency can exist without obligation, and order can emerge without permanence or permission, even when observation suggests stability is borrowed, conditional, and quietly temporary rather than guaranteed. There was no dramatic announcement because there was nothing dramatic to show, just a consistent signal implying that the foundational rule was not absolute, only reliable until it wasn't. The discovery did not overthrow physics. It quietly suggested that physics had been leaning on something it did not fully understand. According to everything we know, this should not be here at all. In science, the extraordinary is rarely shouted. A discovery that challenges fundamental assumptions cannot simply be broadcast without careful scrutiny. Researchers understand that the cost of premature claims is not ridicule alone. It is the erosion of trust in the entire framework. Foundations are fragile, and even a hint that they might be compromised invites intense scrutiny from every corner of the field. Institutions reinforce this caution. Peer review, replication, and internal debate act as buffers against hasty conclusions. A result that contradicts long-standing principles is examined repeatedly, recalculated from every angle, and often delayed for months or years before it reaches public discussion. The rules of evidence are applied more stringently when the stakes threaten the credibility of the discipline itself. There is also a cultural element. Scientists are trained to value certainty over excitement. Announcing that the basic assumptions of reality may be flawed is not thrilling to peers. It is destabilizing. Careers, funding, and reputations can suffer if the finding is misunderstood or overhyped. As a result, groundbreaking results are often whispered first, tested quietly, and contextualized carefully, rather than presented with sensational headlines. This hesitancy should not be mistaken for fear of being wrong. Scientists welcome correction, contradiction, and refinement. What is feared is the absence of guidance, the loss of a framework that allows exploration to proceed at all. Without a stable ground, knowledge cannot accumulate, methods cannot be applied, and inquiry becomes directionless. Science doesn't fear being wrong, it fears being directionless. At first glance, the anomaly seemed contained, isolated to a single experiment, a single measurement, a single data point. That is why it was manageable, why the researchers could study it without immediate alarm. But the discomfort did not stem from the discovery itself. The real unease emerged when they considered what it implied about the structures underlying everything they had assumed to be consistent. Causality, for instance, no longer appeared as rigidly linear. The effect that should have followed a predictable sequence seemed to exist independently of its expected cause. Time itself became a less reliable guide, as if the framework of past, present, and future could flex in subtle ways that the instruments could detect, but intuition could not. Even the rules governing how states transform into one another seemed conditional rather than absolute, like habits rather than laws. The discovery exposed a symptom of a deeper conceptual flaw. It was a hint that the language and models used to describe reality were limited, incomplete, and quietly inadequate. For decades, science had relied on equations and assumptions to translate observation into understanding, but here the translation faltered. What appeared to be a material anomaly was actually a symptom of how human understanding imposes order on an underlying complexity that may not conform to expectation. As this perspective settled in, the weight of the discovery shifted. It was no longer about an object, an event, or a measurement that broke a rule. It was about the fragility of the framework used to define what is possible at all. The anomaly was a mirror, reflecting a conceptual blind spot rather than a tangible threat. Its existence forced a reconsideration of the very foundations of scientific reasoning, revealing that certainty had been assumed, not proven. This wasn't a new object. It was a flaw in how we describe reality. For months, researchers ran the same experiments, double-checked every variable, and recalculated equations, seeking clarity in familiar terms. At first, the work was technical, mechanical, almost procedural. Each step had a purpose, each measurement a predictable interpretation. Questions were framed in the language of cause and effect, of inputs producing outputs, of systems constrained by known rules. Gradually, that approach began to falter. Every explanation led to more questions, each answer opening doors to contradictions rather than clarity. Mechanistic reasoning, once a reliable tool, no longer sufficed. The patterns observed could be described mathematically, but the description offered no intuition, no causal narrative that felt coherent. It was as if the very act of explanation had become insufficient, like trying to navigate a landscape where the landmarks keep shifting beneath your feet. At this point, scientists experienced a subtle paralysis, not fear, not resignation, but a conceptual pause. The questions they had always asked no longer yielded meaningful insight, asking how assumed a framework that no longer aligned with the anomaly. The usual strategies, refinement, approximation, isolation, led only to more incongruities, revealing the limits of understanding that had previously felt infinite. It was not ignorance that constrained them, nor incompetence. It was the realization that the very questions posed to nature had become misaligned with reality itself. The tools of inquiry were intact, but their application had lost direction. They didn't lack answers. They lacked questions that still made sense. When an anomaly challenges a single experiment, it can be contained, studied, and contextualized. But when its implications ripple outward, the scale becomes incomprehensible. The rules that once appeared immutable now feel provisional, leaving every layer of the cosmos open to reconsideration. If a single principle can fail quietly in a lab, what does that imply for stars, galaxies, and the vast web of matter that structures the universe? Cosmology, built on the assumption of consistency, suddenly faces questions it never had to confront. The predictable expansion of space, the formation of structures, the progression of time from past to future, all are now susceptible to subtle reinterpretation. What was thought to be inevitable may, in fact, be conditional. Observers who measure and model the universe rely on regularities that now appear, at least in principle, negotiable. The implications stretch beyond physics into the very language used to describe existence itself. Matter, too, is less secure than assumed. Particles, fields, interactions, all that defines substance, may adhere to patterns that are local, transient, or context dependent. The certainty of cause and effect within atoms, the reliability of interactions over time, these become provisional statements rather than guarantees. Even the flow of energy, the stability of orbits, the coherence of chemical processes, all remain intact experimentally, yet conceptually fragile. Time, perhaps, is most affected. If the rules that govern transformation and sequence can bend in subtle ways, the arrow of time may be more an emergent approximation than an absolute directive. The progression from past to future may continue to appear smooth, while underneath, the assumptions enabling that smoothness are quietly tentative. The universe still works. We just no longer understand why. For centuries, the framework of reality has felt stable, almost comforting. Objects behave as expected. Events follow sequences. Cause produces effect with a reliability that allows life, thought, and civilization to proceed without constant interruption. That underlying predictability is so thoroughly woven into experience that it shapes the way we perceive ourselves, plan, and remember. It forms the invisible architecture of understanding, quietly guiding intuition and expectation. Now, that architecture shows subtle cracks. The anomaly, the rule quietly bent or broken, forces a reconsideration of what was once assumed unassailable. Stability is no longer absolute. Sequence is no longer guaranteed. Cause and effect are no longer fully trustworthy. These shifts are not catastrophic, but they are disorienting. Reality continues to operate smoothly, but the assurance that underpins every choice and every prediction has softened. Life proceeds, unbroken in appearance, yet awareness of fragility changes perception. The ordinary events, walking, conversing, observing, carry a new subtle tension. Even if nothing in the environment has changed, the understanding of what is possible and what cannot occur has been challenged. The mind adjusts, recalibrating what it can rely upon, what it can predict, and what it must now regard as provisional. Existence itself becomes slightly more precarious, not because the universe has altered its rules overtly, but because the narrative constructed around possibility and expectation is less certain. The world feels familiar, yet the familiar itself no longer provides complete assurance. The quiet awareness that something fundamental is unresolved shifts the perception of reality without altering reality itself. Nothing changed today except the story you tell yourself about what's possible. The anomaly left a question that refused resolution. It was not a matter of missing data, nor of incomplete measurement. No amount of repetition, no refinement of instruments, no expansion of observation could dissolve the unease it produced. Each new data point only reinforced the consistency of the phenomenon, confirming that the issue was not error, oversight, or randomness. Science thrives on questions that can be answered through investigation. Yet this was different. It demanded reflection rather than calculation, understanding rather than measurement. The usual tools, formulas, simulations, and controlled experimentation offered clarity in every other domain, but here they illuminated only the edges of a deeper uncertainty. The more precisely the universe was probed, the more the problem persisted, immovable, exact, and silent. It was an existential puzzle hidden inside empirical research. The anomaly was not dramatic. It did not announce itself with spectacle. Its power lay in its persistence, and in the subtle ways it undermined assumptions. Each observation confirmed the rule had been bent, yet provided no guidance for reconciling that bend with the established order. Knowledge grew around it, while the foundational question remained untouched, immune to expansion. Ultimately, it became clear that some aspects of reality cannot be fully mapped, controlled, or even rationalized. Science could describe, model, and predict in every familiar context, but this discovery pointed to a boundary where explanation reached its limit. The question did not vanish with more information. Some discoveries don't add knowledge. They subtract certainty. The anomaly remains unchanged and unannounced, quietly occupying its place in the structure of reality. There are no conclusions to draw, no solutions to offer, and no predictions that can be made with confidence. The universe continues its operations as before, obedient to patterns that appear familiar, even as the foundational assumptions behind them wobble unseen. No reassurance can be provided because the significance of what has been observed cannot be framed within the comfort of expectation. It does not promise catastrophe, nor does it suggest revelation. It simply exists, quietly and persistently, like a note left in a margin that no one was meant to read. The normal course of events goes on, yet awareness of the anomaly subtly alters perception, introducing a quiet tension that lingers without explanation. There is no drama in its presence, only a steady, unavoidable reminder that the frameworks used to understand the world are provisional. What was once considered absolute is now a tentative story, maintained for convenience rather than certainty. Observers may continue their routines, measure phenomena, and apply laws with precision, but beneath that smooth operation lies a fracture that cannot be repaired with further inquiry. The anomaly does not shout. It does not draw attention. It simply is, persisting in the margins, resisting interpretation, and leaving only an emptiness where understanding should reside. Its quiet persistence is more unsettling than any sudden revelation because it offers no resolution, no next step, and no closure. The world remains intact. Yet, in the stillness, the mind cannot ignore it. It waits, unannounced, and lingers in thought, in reflection, in every quiet moment that follows. Hours later, it is still there,